Welcome back. Myself Padala Rajashekar, Assistant Professor, Department of Civil Engineering, SR University, Warangal. So today we are going to discuss another topic in hydrology subject. So the main important thing is that runoff. So again once again I want to tell about the runoff. Then we will go into in-depth one as a glimpse. So for an instant, if we are considering this is as a river, so these are the sub tributaries for an example, and this will be the outlet. So this river and this entire area we call it as watershed. This entire area we call it as river area, we call it as watershed area. So if certain amount of rainfall is happened in this particular watershed, and after accounting losses, the final one whatever we are collecting at outlet is called runoff. That means there is a rainfall, there is a losses which will give you runoff. This is the equation. So there is a kind of rainfall is happening in this particular watershed, and after accounting the losses, the whatever left over the water we call it as runoff, which is flowing on the surface of the land. That's what here I have mentioned here in a text, where runoff means that draining or the flowing off. Flowing off means runoff of precipitation. Precipitation means rainfall from a catchment area, watershed area, basin, everything is correct only through a surface channel. That means here we can see river network, and this network will be collected at the outlet. Runoff is that portion of rainwater which ultimately joins streams and rivers. That's what I told. For example, here there is no stream. This may be the residential area or commercial area or agriculture land or else forest. This entire water will be collected to this tributary, and this tributary again it is collected to this mainstream, and this mainstream is collected to the here outlet location. It is an important output produces by the catchment for a given input of the rainfall. That's what to understand the basin, to make sure that what we need requirements to develop that particular basin. The runoff is very important and crucial parameter which we need to understand for the development purpose of the watershed for future generation people, like sustainable way. That means we have to store the water, as well as that storing the water which should be useful for future generation people. And the things, there are some kinds of flow means surface flow. Surface means runoff, surface runoff, over land, whichever both are the correct. Over the land, like over the land or surface runoff, both are the same. This comes under this one interflow. There will be another one flow, and there will be groundwater flow. So for example, if you are taken like this, here it will be surface flow, here it will be interflow, here it will be groundwater runoff. Now we will see the flow that travels all the time over the surface as open channel one reaches the catchment outlets. That's what I discussed previously. It will travel and it will go to the outlet. Interflow is the part of precipitation that infiltrates and moves laterally through upper crust of the soil and returns to the surface. That means here the water will travel from here to here, that is a little distance of the soil, and it will come back to soil and returns to the surface at the location. Again it will come back to the top surface. And the groundwater flow is a portion that undergoes deep percolation and reaches the groundwater table. So now you understood about the runoff and types of runoffs, I hope. Now I want to show in a visual way. Like in this picture, you can see, for example, these are the plants, and this is some kind of water body, and this is also some kind of water body. To understand, I am telling. And here is a groundwater and a base flow. So now this is a precipitation has happened. Precipitation is happened here, and this is the evapotranspiration, as I discussed in the earlier classes. Evaporation means it's with respect to the water bodies, and transpiration means with respect to the plants. And now whatever the runoff after losing losses, the runoff is happening on the particular surface, we call it as overland flow. Here we can see also called as surface flow. And inside means it a little depth from the top surface to the soil. Whatever the water is infiltrated, and it is going this way and coming out and joining to the particular stream is called effluent. Effluent means, as I discussed in the earlier class, effluent means is good, gaining stream. That means it will gain some water through groundwater. And influent means losing. It is losing the water to ground. That means if effluent will comes, the water will come from ground and it will reach to the river and it will flow. That is, now you can see through flow means that is called subsurface runoff or interflow. As I mentioned previous slide, there are three groundwater flows: interflow and surface flow. It is divided into two types: prompt interflow, delayed interflow. There will be two types: prompt interflow and delayed interflow, two types. And there will be another kind. This is the water table symbol, and base flow. Now, basically, you understood there will be prompt and a delayed interflows, also two types. Now, based on time delay in joining the runoff into the streams, the runoff is classified into two categories. That means, for an instant, if there is a rainfall, immediately after the losses, that means filling ponds, lakes, and taking the infiltration and everything after the losses, the runoff is directly we can see on the surface of the land. There will be direct runoff, base flow runoff. Now direct runoff means runoff with without much delay in joining the stream. That means I told direct means the name itself defines directly. That means whenever the rainfall happens within one day, or depending on the characteristics of that particular watershed, the runoff will immediately starts the runoff will start joining to particular nearby tributaries and tributaries and mainstream. That means this includes there are three types of things: surface runoff, interflow, and groundwater flow. Surface runoff is the one which we can see here, and prompt interflow and channel precipitation. These three types included. Coming to the base flow. Then what is a base flow? Base flow is nothing but runoff which joins lately into the streams. So it will take some days or weeks or months depending on the watershed characteristics. Now, here base flow means base flow is itself. You can see where is base flow here in this graph. This is a base flow. Okay, here base flow is there. Now here we can understand base flow means it will starts delay. That means delayed interflow and ground flow. That means from here we can understand surface flow, it will come quickly. Interflow also will come quickly, but two types. One is a prompt delayed. Prompt will go, delayed will stop, and groundwater. So in this, surface flow and interflow will impact quickly, and groundwater flow and in interflow it will be delayed. One is will come little late, and it will join the stream. Now, if we want to understand further, we need to go little about the types of rivers like perennial river, non-perennial river, epiperennial rivers. If we understand about the rivers, then automatically we can understand about that nature of the river, how it is. So now I'm not going in depth regarding these things. Flow duration curve. The word itself having there is a flow with respect to duration. That is as a plot of the discharge. Flow means discharge. Uh, there is a plot against percentage of time. So here the plot is drawn with respect to the percentage with respect to the discharge. Percentage of time with respect to the discharge is called flow duration curve. So now use it to study the stream flow variation. Obviously this is used to how it is fluctuating with respect to time, like percentage of time, and discharge, also discharge for frequency curve. Next one, another important one is flow mass curve. It is a plot of cumulative discharge volume against time plotted in chronological order. That means time versus cumulative flow volume, we can tell in a simple words. Next, classification of streams. I told previously that we have to understand, for example, if there is a river called X, there is a X river, then we have to understand whether it is perennial river or non-perennial river or ephemeral river. That means throughout the year, in a river, for example, I want to show here, there is a catchment. This is called outlet. So this watershed is having continuous water in this particular river, that is called perennial river. Only with respect to sea, also known as permanent rivers. Perennial rivers also known as permanent rivers. Perennial streams are those which exhibit a continuous flow of water throughout the year. That means there will be continuous water throughout the year. And non-perennial rivers are the streams having no flow at least some part of the year. That means you can consider it as seasonal, like monsoon season. There will be, they do not have a constant flow throughout the year. So that is a thing. And you can consider in our Indian conditions, I can tell perennial river means river Ganga. Why river Ganga means there will be addition of snow melt, and that's what every time we have continuous flow. And non-perennial means you can consider as like Godavari, like you can take Krishna or Kaveri, which comes under non-perennial rivers. Now, ephemeral streams. What is ephemeral streams? So it's bit and we have to understand the thing. Perennial means okay, Ganga, there will be some snow melt, so such that it will be always, it is having permanent river, there won't be any kind of dry. And Godavari, Krishna, Kaveri, it comes under non-perennial because they are depending on mostly on southwest monsoons and northeast monsoons, so they comes under non-perennial rivers. Then whatever the epiperennial. So ephemeral rivers are simply, they are completely temporary rivers. That temporary rivers means short-lived river. That means the stream which exists for a short period, the stream that flows during the period of rainfall in the immediate locality. That means you understood, it's a ephemeral river is completely different from perennial and non-perennial rivers. Now classification of the streams, that means in terms of that, based on the contribution of groundwater. So particularly here I want to make sure that this classification is based on only with respect to groundwater contribution. How much it is contributing to ground is very important. That means as I mentioned in the previous peak, the thing which is giving from ground to surface water, which is giving the water, that is gaining river. Effluent, that is effluent, which is losing is influent. So gaining stream is that the stream which gets water from ground, as I told. So gaining means, see, gaining means, see, now here they have given some arrow mark. You can see here some from groundwater table, the water is going and adding into this particular river. Already there will be some amount of water in this river already. So additionally some more amount of water is adding to this river through medium as ground. A river gains water from the water table, that is called effluent streams, as I mentioned. And now the particular aspect, influent streams means it won't contribute anything to the river. That means here you see there is a ground surface, there is a river, and rechargeable zone is up to here, and groundwater flow is in this direction. So previously groundwater flow is direction is this side, that is called, it will be benefited for the river network like stream in terms of effluent, and it is not benefited with respect to the stream. So it is going in this direction. Though these are the influent, that means it is benefiting with respect to the groundwater. So now another kind of the stream is called virgin flow or natural flow. The stream flow which is unaffected by works of human is called as natural flow or virgin flow. So any river which is not affected by the works of humans, that is called virgin flow or else natural flow. When there exists storage or diversion works on stream, the flow on the downstream channel is affected by the operation characteristics of these structures and hence does not represent the true runoff unless corrected by the diversion of the flow and return things. That's what we discussed. In a simple words, it should not be affected by the humans works. Now the natural flow as well as the virgin flow, as we discussed previously, volume in time, that means delta t, is expressed by water balance equation. Here also some kind of water balance equation we can see. Rn is nothing but natural flow volume in time delta t. R naught is observed flow volume in time delta t, gauged flow, and we are some kind of volume of return flow from irrigation, domestic water supply and industrial use. Vd is nothing but volume diverted out of the stream for irrigation, domestic water supply and industrial use. E is nothing but net evaporation losses from reservoir on the stream, and Ex is nothing but net export of water from the basin, and delta S is change in storage volumes of water storage bodies on the streams. Now we understood what is runoff, and we understood what are the things are there in runoff, like effluent, influent, and the things, other basic things we learned now in previous slides. And now we want to discuss and we want to know what are the things are there, methods, like methods to estimate runoff. So the first one is called rainfall runoff correlation. It is very important and we have to understand. That means if there is a rainfall after losses, what is a runoff in a simple sense. So the relation between rainfall in a period and the corresponding runoff is a quite complex and is influenced by several factors related to catchment and climate. One of the methods to estimate runoff is to fit a linear regression line between precipitation and runoff and to accept the result if the correlation coefficient are near to unity. Here I can tell R is equal to A capital P plus B. That means A means this is the equation we can use, B means this is the equation we can use, N is the number of observations sets P and R, and the correlation is this one. This is the formula we can use. So methods to estimate runoff, another one in that empirical equations. So empirical equations means with a knee sense of observation in the region of their activity, many engineers of the past have developed empirical runoff estimation formulae. So these formulas are applicable only to regions in which they are derived. So that is one of the thing we have to observe. Rainfall runoff relation addition, third, fourth parameters like climate catchment. Now there are three kinds: 1, 2, 3. Business percentage, Barlow stable, and strange stable. So this Barlow stable is only for Uttar Pradesh, and strange stable is only for Karnataka and Maharashtra, and used for business percentage used for catchment in Vidarbha and Madhya Pradesh. As they mentioned clearly here, these are applicable only to the regions in which they were derived. Now next, another empirical kind of the thing with respect to the Western Ghats and Deccan Plateau, there is a English and D'Souza formula. So as a result of careful stream gauging in 53 sites in Western Ghats, English and D'Souza evaluated two regional formulas between annual runoff R in centimeters, annual rainfall P in centimeters as follows. So for Ghat regions, this is the Western Ghats region, this is the formula, and for Deccan Plateau, this is the formula. R is equal to 0.85 P minus 30.5. For Deccan Plateau, R is equal to 1 by 254 P into P minus 17.8. This will be little boring because the equations formulas we have to understand, and the concept is very important. Why we are doing, why we have to estimate, for what use. It is the most important. That means if we are able to find the runoff, then from the runoff we will understand how much that particular catchment is getting the outcome of the runoff. From that we can make like kind of check dams or any kind of things. From that we can make sure that watershed management. So another kind of empirical formula is coast loss formula. So coast loss analyzed the rainfall and runoff and with respect to the temperature data. So this is one of the important addition that what Scofield has done, that in the term TM is mean monthly temperature of the catchment in terms of degree centigrades, and rest others is like runoff, rainfall and losses. Losses are very important in taking these things. So next, so we have seen three kinds of things. Now another one is a watershed simulation, SCS curve number. This is one of the famous method which still using in research field, SCS curve number. Soil conservation service curve number, one of the most successful one, and Horton's infiltration, hydrographs, infiltration indices. These are the things also they are doing research. Now coming to the hydrographs. So hydrograph is a plot between discharge in a stream versus time in a chronological order. So here they are telling hydrograph is nothing but with respect to time and discharge we will get some understandable thing. If time increases like this, you can see if it will go up to the peak for certain duration. Understood? So if there is a rainfall event up to certain time, it will be more rising. After that, it will go back to decline. That is, this is called a rising limb. This is called falling limb. So up to certain distance, it will rise, and after that, obviously, it will decline. So this we can understand the nature of the watershed. As I mentioned many times, this is watershed, and this is tributaries, this is mainstream, this is runoff, this is outlet. Outlet means the entire water, whatever the received, the rainfall, the entire rainfall is received for this catchment or watershed is measured at particular location. That particular location is outlet location. This outlet location is measured discharge value in terms of meter cube per second, and this meter cube per second is plotted with respect to time. At that particular day how much, at that particular day how much. From that we will understand in particular monsoon seasons, or for perennial rivers, non-perennial rivers, what is the effect and how it is acting when the monsoon season is there. Is there any more or less, we can understand through these hydrographs. So factors affecting flood hydrographs and flood hydrograph or runoff is nothing but physiographical factors and climatic factors. That means uh, physiographic means physical characteristics. For example, as I discussed many times, this is a river, and this you can take some tributaries. So physiographical means what is there on that particular watershed. Built up area. Built up area means commercial buildings, residential buildings. What is agriculture? What is agriculture? What is barren land? And what is forest, and what is water bodies in that particular thing. Not only that, not only that, basin characteristics, like what is the shape of the basin, what is the size of the basin, what is the slope of the basin, nature of the valley, elevation, drainage density. These all things comes under these things. Now, infiltration characteristics, nothing but land cover, soil type, geology, and lakes, these all things. Climatic things is like storm characteristics and initial loss and evapotranspiration. Now, I told with respect to the size, shape, these all things. Now, with respect to the shape, you can see if it is in this shape, the discharge is like initial stage only, the peaks we can see. If it is this stage, the peak is touched after some delay. If it is in this stage, the peak touched and declined and touched. Depending on this, the size of the basin, the shape of the basin, this will be affected. That means there is a peak got, then there will be a decline, like falling curve, then there will be another rising curve. So these kind of things we can observe with respect to the shape, size, and everything will comes. Now coming to the size, small catchments behave different from the large ones in terms of relative importance of various phases of runoff phenomena. That means small catchments overland flow is predominant, Large catchments, these are suppressed. That means the peak discharge is it will vary depending on the catchment size. If it is small size, it will be one way, and it's large size, it will be another way. Now slope. If the catchment, that means if the watershed is having a steep, then flood will happen very quickly. If catchment is flat, when comparatively the flood is reduced, that means it will be less flood chances are there for flat terrain when compared to the steep. That's what the losses will be more in terms of hilly terrains when with respect to the heavy rainfalls, landslides also we can see. So now drainage density. Drainage density means, as I mentioned previously, there is a drainage, there is a network. This is a watershed, and here there is a river network. This streams are there now. This kind of streams like a tributary, sub tributary, main streams. This is called mainstream, and these are the tributaries, and these are the sub tributaries. So that's what here they mentioned in two different ways. For example, if drainage density is more, that means density means number of tributaries or sub tributaries. If drainage density is more, then there will be quick disposal of runoff down the channels. That is, if more means more peak will come, if less means less peak will come. Now you can understand here the limit. Previous one is this one, like this is this, and this is this. So steep will go more flood, and more drainage density, fast response, less drainage density, less response. That means less drainage density in the term. This may be entire area, maybe with respect to the forest cover, and this less drainage density means may not be that much effective. Now another one, land use, land cover. As I mentioned from previously, what is the vegetation cover, what is the forest, what is the built up area, and what is the water bodies. Depending on all the circumstances, uh, the runoff will be analyzed. For example, if this is a watershed and this is a watershed, we can understand. If more network, that means if less network, more network, depending on the physical characteristics. Like if for example forest is there, more forest is there, for example, so runoff will be less. If built up built up area, like kind of commercial and residential, there we can see runoff will be very high, because the absorbing capacity of particular built up area is very low, because everything is covered with respect to uh, structures, roads, we can tell commercial buildings, residential building, industrial building, concrete, everything is covered, so there won't be any intake of infiltration. So if infiltration is not there, that infiltration amount of water is added, in terms of runoff, so more runoff will be there for where built up area is more, and less runoff is there with respect to the forest area. So now climatic parameters, as I told, physiographical factors and climatic factors. Now climatic factors also one of the things which they like intensity of rainfall, duration and direction of the storm, three important affecting the shape of the flood hydrographs. Now important one, rising limb and crest segments are influenced by storm factors and catchments factors also, but rising limb is influenced by only the factors. That means I told there will be a hydrograph with respect to time. This is rising limb, this is falling limb, okay, and this rising limb are influenced by some storm characteristics and catchment characteristics, but resection limb is influenced only with the catchment factors, not storm factors. Now another topic I want to go with respect to the reservoir. So now before going on onto this topic, reservoirs, types of reservoirs. That means there will be first kind is storage reservoir, flood control, multi-purpose reservoir, distribution reservoir. There are four types of the things. First one we will see storage or conservation reservoir. This we can see the one picture which we can be easily understandable. A storage or a conservation reservoir can retain such excess supplies during periods of peak flows and can release them gradually during low period. That means if you are taking one hydrograph, this is a peak one, so it will store the water when peaks flow, and it can release the water when it is going low flows. And next, use of water directly from river or stream city, like it can be used for city water supply, irrigation, hydroelectricity. It may fail to satisfy consumer demands during extreme low, because if there is very low flow, it cannot provide the water, and if it is high also, very peak floods also, it cannot use to the consumer demands. It may be become difficult to carry out their operation during devastating floods. So these are the some drawbacks which we have to consider. Advantages is nothing but it can obviously it can control the floods and reduce flood damage below the reservoir. Next one, second one is flood control reservoir. A flood control reservoir, generally called a flood mitigation reservoir, or stores a portion of the flood flows in such a way as to minimize the flood peaks at the areas to be protected downstream. So this is some kind of the things we can understand. So now types of flood controls reservoirs are storage and retarding reservoirs. So storage means a storage reservoir having gates and walls installed at its spillways, and its slice outlet is known as storage reservoir. Retarding reservoir is not a reservoir with uncontrolled and ungated outlets is known as retarded basin and retarded reservoirs. Next, another one is important, multi-purpose. Multi-purpose itself having multiple uses. Like reservoir planned and constructed to serve not only one purpose, I told you, and but various purposes together. That means it can be water supply, it can be flood control, soil erosion control, and environmental management, hydroelectric power generation, navigation, recreation, irrigation. This is one of the example one which we can see multi-purpose is Bakra Dam is a concrete gravity dam across the Satluj River and is near the border between Punjab and Himachal Pradesh in the northern part of the India. And distribution reservoirs. Distribution reservoirs is nothing but connected with the conduits of a primary water supply used to supply water to consumers according to fluctuations in demand over short term periods and serves as for local storage in case of emergency. So now the another one basic thing is that how to select that reservoir location. So some criteria they given. So that also we should understand. First, the reservoir should not construct where not to be located or nearby the settlement areas. That is the first safety concern. And be on water accumulated areas, that is watershed management perspective. Be on like gentle slope, that is environmental or safety, and have a sufficient volume of water, that is consumption and economic things. These all the criteria that we have to look at into that. So now next one is reservoir. Okay, now reservoir yield. Reservoir yield means the quantity of water which can be withdrawn from storage in the reservoir. That means reservoir is determined by rate of flow of the streams into the reservoirs, losing due to evapotranspiration from the reservoir surface, and the volume of water impounded in the reservoir. Yield means, in a simple sense, yield means quantity of water which can be withdrawn from the storage in a reservoir from a given period of time. Now I want to go with zone of storages. So zone of storages means the storage in the reservoir are divided into some zones based on the functions like surcharge storage, useful or live storage, date storage, valley storage, bank storage. I want to go with one figure you people can understand easily. Now this is the construction of the dam, and here we can see this is called spillway gates. That is most commonly we can understand. If the water level is here up to the spillway to the dam normal pool level, that is called surcharge storage, that is a maximum pool. If the maximum pool here, And if the water is near the dead storage, as I mentioned, there are many kinds like dead storage, live storage, valley, bank, surcharge. So this is called this is the outlet of the reservoir for the reservoir. So here the pool is called minimum pool level. So as I mentioned, this is the between this things, normal pool level to here we call it as live storage, and below minimum pool is called dead storage, and this is called valley storage. This entire thing structure is called reservoir. Surcharge storage, here we can see surcharge storage comes between normal pool and maximum pool. Now we come to able to know live storage, dead storage. Yeah, here is live storage, here is dead storage, and valley is here. And these are the things, zones of storages. Now reservoir sedimentation is a difficult problem, economically solution of which has not yet been developed except for providing a bit greater dead storage to accommodate the sediment deposited during the life of the reservoir. So some kinds of things are there, that is the river watershed can depends on nature of the soil of the watershed, topography of the watershed, vegetation cover of the watershed, and intensity of the rainfall, soil conservation and management techniques. This kind of things to sedimentation. And if it is as I mentioned here, it will be the heavy density currents and fine density deposit. This is as we know that scoring sluice and upper supply sluice, and lighter density will be like this, always clear, relatively clear water. So control of sediment in reservoirs having need to be done. Proper selection of the reservoir, control of the sediment inflow, and vegetation cover and soil conservation methods, crop rotations, terracing, and small embankments, and a removal of deposited sediments, removal by sluice during the flood time, construction of a dam in stages as afforestation, and control of deforestation. And up to this, okay, thank you.